Hi, this video is to show you how to use a video of your Mousetrap car to analyze the car's speed over a 10-meter track. So first note that the Google Classroom assignment has the video analysis worksheet. I'm going to demonstrate how to set up and do some of these calculations. The classroom assignment also has folders with videos in them. So I'm going to be using a video editor on the classroom laptop, but you should be able to do something similar with Wii Video, available by searching on your Chromebook for Wii Video. So the first thing to notice, if you open up one of these videos in the Google Drive folder, you're not going to be able to advance frame by frame or do very detailed analysis using the playback. You can find your video and see what's happening, but you're not going to be able to get into the frame by frame. So you're going to need to download video first, and I had already downloaded one earlier, and then this will probably need to be uploaded into a video editor. So I'm using this video editor that's available through Classroom, or excuse me, it's available on the school laptops. This may not be the most ideal video because it's difficult to see exactly where the car stops or where it crosses the 10-meter line, but I think we can work with that with some detailed analysis. Okay, so if I'm using the laptop, I'm going to open this VLC media player, and I need to view advanced controls and select this arrow to advance one frame at a time. Let's see what that looks like. So it looks like advanced controls were available down here. Okay, so it looks like I can advance one frame at a time. And the first thing I need to do is just determine how many frames are in 1 second of video. So I'm going to back all the way up to 0. And I'm going to advance and count frames until I get to 1 second. I'm finding out how many frames are in 1 second of video. So I'm just going to count 1, 2, 3, 10, 11, 20, okay, at 30 clicks, I changed from 0 to 1 second. So number of frames in 1 second of footage is 30. Now the length of time, the length of one frame of footage in seconds is 1 second divided by 30. So 1 divided by 30, which equals, use a calculator, 0.03 repeating. Okay, so 1 divided by 30 equals 0.03 repeating. Maybe I'll go 4 decimal places. Okay, now that I know the number of time in one frame, I can get very specific about the amount of time it takes for the car to move a certain distance. We'll start with the whole race here. So the first thing I want to do is count the frames in the whole race, and then use that information to determine the time it took to cover that distance, and then use that to calculate speed. So I'm going to go back to the video recorder. Now, I'm not interested in starting at 0 now. I'm interested in starting exactly when the car begins to move. So right at that moment that it's let go, I'm looking at the front wheels and looking for that moment at which the front wheel starts to move. forward. I think it's right here. So I'm going to count frames to complete the race. I'm at 30. That's 100 frames. Now I'm starting to look carefully at where the 10-meter mark is, and if I can figure out on the tile where it's going to cross that. So this is 101. I'm going to guess that this is at 163 frames. This line here lines up with the 10-meter mark. So the frames, and a couple of times my mouse I think moved from that button, and I might have counted a frame that didn't actually advance, but I'm going to go with 163 frames. So the time to cover that distance is 163 frames times 0.03 repeating, which is going to be equal to this times 163, which equals 5.43 repeating seconds. So the time in seconds is 5.43 repeating. Now the average speed over the whole increment, I have to figure out what the whole increment is. So the whole increment is 10 meters. So 10 meters divided by 5.43 repeating will tell me my speed in my average speed in meters per second. You probably already noticed that the car speeds up and slows down, but the average speed over the 10-meter increment is 10 divided by this number. So I should be able to do 10 divided by answer. Okay, and I'm just going to round to the nearest hundredth. 1.84 meters per second is the average speed over 10 meters. Okay, this is the number that we're most interested in reporting for our car's speed over the 10-meter race. I additionally would like you to break this down and find the speed in each meter. In this case, you're going to be taking 1 meter divided by the time, 1 meter divided by time in seconds. Okay, break it down for each meter so that you can note where your car is accelerating and where it's decelerating, and then do the exact same thing for a 10-meter race on tile.